Geometry, Patterning, and Algebraic Reasoning, Standard 2.3. Okay, so here we're going to look at area and perimeter models. Actually apply the previous video to geometric situations. So the perimeter is the total distance around a shape, and to find the perimeter of a shape, if it's a polygon, which we'll talk about later, you simply add up the length of every side. Okay, so that requires the skill of adding polynomials. So first example here, find the perimeter. This appears to be a trapezoid, a isosceles trapezoid specifically, and we'll learn that later. But what we need to know now is these little hash marks mean that these two sides are the same length. And we'll talk about, again, vocabulary terms. So we have to understand that both of these sides are 3x squared plus 2x plus 1. Perimeter means to add up all the sides. Okay, so I've done that here. Notice I have 2 of these 3x squared plus 2x plus 1s. And then I combine like terms. Remember, when you add polynomials, you do not change those exponents. Okay, so I have only this 1 4x to the third power. I have this 3x squared and this 3x squared, which makes 6x squared. I have this 4x, this 3x, that's 7x, plus 2x makes 9x, plus 2x more makes 11x. 3 minus 2 is 1, 1 plus 1 is 2, 2 plus 1 is 3. Okay, so that's the perimeter of that shape. Area is the number of square units within an object. How many little square units fit in there? To calculate area, you use one of various area formulas, but multiplication will always be involved in some manner. Okay, so an example here is a simple rectangle, 4x plus 8 times 2x plus 3. The area formula for a rectangle is simply length times width, but we need the skill of multiplying polynomials. So from last time, we know that this requires you to distribute the 2x and to distribute the 3. This also requires you to know that you multiply the coefficients but add the exponents. 2 times 4 is 8, 1 plus 1 is 2, then 2x times 8 is 16x, because 2 times 8 is 16 and we'll have the x. 3 times 4x is 12x, 3 times 8 is 24. Then you combine these middle two to make 28x. So this is your area. Now, what we didn't have on either of our examples are units, so it is worth mentioning this would be units squared. The previous example would have been just plain units. Now, we do have, for the Georgia standards, they like these sort of composite shapes like this. And what you can do here is make this 2 different rectangles. And you could make it into left and right by drawing a line here and figuring out the dimensions of each. I chose, though, to go top and bottom. So the area is going to be top plus bottom. Now, area will require multiplication, but when you do a composite figure, that's 2 different shapes. Then you have to add the areas of those 2 different shapes. So what I did was drew a line right here. Okay, and for the red, the top, if you draw a line here, it's clearly 2x plus 2 times 1. 2x plus 2 is, you can think of that as the length or the width, whichever. It never matters which one's which. But 2x plus 2 times 1, that's the area of this top rectangle if we connected here. Now this bottom rectangle clearly has 3x minus 1 on one side. And these hash marks, again, are key because since the 2 sections here are the same length, that means that each one is exactly half of 2x minus 2. Or 2x plus 2, excuse me. So that makes it 1x plus 1 if you take half of that. Okay, so I did 3x minus 1 times 1x plus 1 again, because each of these are 1x plus 1 for this bottom rectangle right here. We multiply in both instances, combine like terms to get 3x squared plus 4x plus 1. So the standard says using algebraic reasoning, add, subtract, and multiply single variable polynomials. So again, you could look at the previous slideshow and it's much the same, but the idea here is to put it in a geometric context, which we did.